Okay, I'm going to share my screen. Okay, can you see that? It says advanced views, techniques.
Yeah, the book.
Okay. So this is pretty much the end of, I think this would be chapter, or this is the beginning of chapter 11. 11 and 12 is what we're covering today, because you know, when they wrote the book, or the new version of the book, they combined chapters of the old book. One concentrates on what the old book did, and then the new one adds all the AutoCAD stuff. Okay, so this is the background of chapter 11 and 12. Now these are called removed and revolved orthographic views. Okay, so when you don't have enough room, this right side view is over here. And so what you do is you put this type of line, looks like a cutting plane line, but it's really a center line. And then you revolve it, but what you do for clarity, you probably, most of the time, you increase the scale where this scale for this drawing is smaller than this scale. And then you would go ahead and dimension this, okay? But like we've always said before, you add views to make sure everything is clear as to what you're making. So even when you look at this pictorial, you can't really tell that this slot is tapered here and there's a hole on the end. So you can see the hole here, and then when you're looking at it from this direction, there's the hole. And then when you look at the front view, this hidden line down here would be this lower corner here. So this clarifies it. Okay, and then this is another example. This is, they call this one a revolved view, because this view is full scale. Whatever you drew that one at, okay, but you just placed it in there. And then you would label the view and then put in there that you just rotated it 90 degrees. And then these are important. When things get more complicated, when the item it has more details, what you've got to do is you've got to add a detail. Okay, you circle where the detail's going to be, and then you redraw it over here, or just what you can do is just copy it, and then you know, you can cut it here, but then you can scale it up, and then by scaling it up, you can dimension it, and you can give all the detailed dimensions where it would be way too crowded over here. Okay, so you would do that. And then here's a partial view. You have your front view, your top view, your pictorial or isometric up here, and then you just do the partial view of this part right here. Okay, but one thing that they don't show on these examples, oh, this one they did. This one's got all the dimensions. Let's see about this one. No, it doesn't have dimensions. But remember, make sure you always put all the dimensions, because as we're progressing in these technical drawings, remember the bottom line is you've got to get to the point where whatever you solve, whatever the problem is, you got to make sure you put all the information, notes, dimensions, etc. Okay, this is kind of the the meat of these two chapters, and that's auxiliary views. Okay, and an auxiliary view is when you have an object that has a slanted surface, or it's not 90 degrees to the other surfaces, you have to draw an auxiliary view. And then you, on the auxiliary view, that's the true size and shape of this surface. And then you would dimension that. Okay, and here is another example of that auxiliary view. And here is the pictorial of it. Okay, now when you draw an auxiliary view, this view is parallel to this surface. And I'm going to demonstrate how to make this easier for you when you draw it. Now, this is still a little confusing, because when you draw an auxiliary view, everything in the back here is distorted. Okay, so then you might, draw what's called a partial auxiliary view. And this is the true size and shape. And this is the one you would probably dimension. Okay, because this clarifies what this surface is, you know, and you would put your notes for this counter bore and the shapes. Okay, and then this is related views. Okay, sometimes you would draw something, and then to demonstrate what it's for, you would use a, in this case they used phantom lines, and you would draw the object that would fit inside here. I don't know if any of you have done any machining, but this is a V block, and then this would have a screw, and this would slide on the V block and hold round material down. You could put a piece of round material in here, and then you'd have a screw come down in here and hold it in there. Okay, and then these are the examples. This is your auxiliary view of this surface. This is your primary view. This is front view, top view, and right side view. And as you can see, this is a pretty complicated part. So you have all this. You pull, this is a detail, that's up here. Then you would dimension that. And then you would also dimension all your views that need to be dimensioned. And then here they've created two more partial views. And then this is the most important one right here, because it would give you the true size and shape of this surface here. Okay, now this is, I actually did this one. I demonstrated this one. And I'm going to show you, I mean, this particular PowerPoint shows you how it works. But then I'm also going to show you my example to give you an idea of how you should tackle it. Okay, but what they've done here is, this is the front view, and I think this is in the book. I think this is on chapter 11, page 13. And so this is the front view, this is the top view. And all this is distorted because when you look at it from the top, you know, you can't see the true size and shape of this hole, as well as that surface. And so the purpose of an auxiliary view is to show that. And so when you click on there it is. There's the auxiliary view. I would take it one step further, and I would draw, and I'll show you on the demo that I did. I would draw this, you know, I would maybe pull this pictorial out farther and then draw this partial auxiliary view, which would be this part just here, because that is the part that you draw. You draw the auxiliary for that purpose, because what you do is all this kind of stuff is distorted because of the direction you're looking at it. So you don't want to dimension any of that. Okay, now what I'll do is I'll play her video, and then I'll do mine. I'll play her video because then, you know, she always comes up with stuff that I don't always cover, and so let's tackle that now. When you do yours, I want you to do yours on AutoCAD, and that's what I'm going to demonstrate. But she's going to do it with freehand sketching, okay? But obviously she must have drawn this either on a drawing board, or maybe she did do it in AutoCAD, and then created these construction lines, and then printed it, and then now she's going to demonstrate it by hand. But when you do yours, don't do that. Here, let me expand this and see. Ah, okay.
In this exercise, we're going to be creating a couple auxiliary views. You can see this object here has two angled surfaces. Each surface has a feature that would not be shown true size in the principal views, that is the front, top, or right side view. So we need to create a couple auxiliary views so that we can get a true size for this counter bore right here, and for this protrusion that has a radius and a hole in it. So we're going to start with this auxiliary view over here on the right, and in the next video we'll create the auxiliary view over here on the top. All right, now auxiliary views, a lot of times you can get away with just drawing a partial view because they're really just adding information. So let's start by drawing a partial auxiliary view of this side here. And that means just drawing everything that's on the surface of this left side here. So I'm going to start by outlining it. Maybe we should take a look at what the object is first to help us visualize. We have an angled block. In the bottom of the block, we have a semicircular hole that's cut out. And then we have this slot going down on this side right here. All right, so we're going to draw the outline. And right here we have this semicircular cutout. So we need to put that in. Now this cutout in the auxiliary view is not going to look circular or semicircular because we're looking at it at an angle. So it's going to be elongated a little bit, but the projectors will tell us by how much. All right, and then in the top, we have the little slot right there, and then we need the counter bore and drill. And that's going to go right here. And that's really the reason we need this view, so that we can dimension this counter bore and drill. And also we can dimension the size and depth of the slot. Now this would be fine if we kept it here, but let's go ahead and do the complete auxiliary view. So in that case, we want to show all the hidden lines and this little protrusion off to the side. So let's go ahead and put that in. And then we need to show what happens to this cutout. So it ends here. We need to put that in. And then connect up the two sides. All right, you can see that by adding the hidden lines and including everything, it really doesn't increase the information that we're giving. So it's up to you whether you keep it as a partial view or complete it and put all the hidden lines in.
Okay, just to add something, my preference for you guys is if you want to, no, I would leave it as a partial view, because sometimes when you add all the hidden lines, it makes it real confusing. Okay, so let's go to the next one, and I think she's going to finish the other side.
Now let's complete the auxiliary view that's mostly on the top here. Again, we're going to start with just drawing a partial view. So that means just the surface.
If you notice these curved lines, remember when we use the technique for transferring distances from one view to the other, you could, from this point, I'm pretty sure, no, I don't want to do that. What they've done is they've taken a compass and they put the compass point here, or they've created an arc from this being the center point, and then they've drawn an arc. And they did that for every feature. And when you do that, it gives you the point, the start points for the features. And then when you project at 90 degrees from this surface, and remember these projection lines, these construction lines are at 90 degrees to whatever the surface is, always.
That has the angled features on it. Let's go ahead and darken in the outline of the object. All right, I didn't do a very good job of doing this radius, so let's redo that. There we go. And we'll put the hole in. Now on this auxiliary view, the whole point is to get this protrusion to be true shape so that we can dimension it. Let's finish by putting in the slot. Right there. All right, you'll notice that I left this side open here. That's because there is no line. The line for the end of the slot really comes right here on this projector. But since we're drawing just a partial view, this would be good enough. Now let's continue by putting in all the features and see how that looks. So we will end the slot, and then we need to put this circular feature in. Right here. All right, we have everything, the slot, we can put the counter bore in. Oh, that's not where I want to put that. And then here where the counter bore, or the drill of the counter bore ends, you're going to see a little oval shape. Right there. All right, so that is the auxiliary view. We can put a center line in here. And we're complete.
Okay, what she could have done is, see this, you got these two edges here. She could have drawn, since, you know, I mean, since she's including the hidden features, she could have drawn a hidden line from here all the way up to here. Okay, now, has anybody noticed something about the right side view?
I mean, I
Is
can
there a
really
mistake?
Make out what it is.
Okay, when we drew the auxiliary view, this feature is part of the surface. Why would you have a line from there to there? See the little, see this line from here to here? This should not be there. Right or wrong? No, no, it shouldn't be there. I'm thinking, no.
You mean the line
From here to
that
here.
sort of goes between the 2 points of the thing that sticks out? Right there, yeah? Is that what you mean?
This here, from here and here on the right side view, because this feature is
Has the same angle.
Yeah, it's at the same angle, and it's at the same surface. So,
Yeah, that is.
so they did an owie. Okay. Now what I'm going to do is I'm going to get out of this, and I want to share something with you. Well, before that, I'm going to let's go through this and see if there's anything. Oh, yeah. Because Thursday I want you to work on the midterm. We'll go ahead and go through the rest of this, and it's not all that as far as your assignments go. It's more just informational. Okay, now here's an example of drawings for casting and stuff. In other words, when you're doing some of these designs, sometimes the dimensions and everything are not the finished dimension. Okay, and here's an example of a casting where, you know, they pour through here, and the metal goes in here, fills this cavity up, and here's a riser for the overflow, and then there's your part. Okay, and then here's another example. Here's a tool, and then they've got the surface is finished, and this is the rough surface. Okay, and then another thing you have to do down the road is you put machining symbols and explain that, okay, you cast this thing, but all the surfaces are rough, and then you have to come back and mill, either mill this or sand it or whatever, and then you have to specify the type. And then in this chapter, they cover surface symbols. And these symbols you have to create, and we'll show you how to create them and then create blocks from them. And then you don't need to worry too much about all this right now, because this is a whole new class. But it's in the chapter, and I do want to show you that when you get into design and machining and stuff, this is like geometric dimensioning and tolerance is a whole new area. Okay, all these numbers placed in these different positions on this symbol have different meaning, and I'll show you one example of that in a second. Okay, and so in other words, when you draw this, you have to tell the machinist, okay, this surface here needs to be machined, or this surface needs to be machined. That one, no. Okay, so that's the purpose of these symbols. This is the surface must be produced by any method, and then when you have this symbol, it means material is removal material is required, and this is you can't, don't remove any material. And it depends on the function of the part. Okay, and then here's, now we've gotten into some welding symbols. Okay, and this is a symbol for a fillet weld. And then this is a fillet weld on both sides. And then the numbers try to give you, you know, about how much it should be. And then here's this symbol with the circle is for welding up and around the whole thing. And obviously this makes sense, a V groove. And this is a square joint. And then this is a beveled groove. So these are different symbols, and these you can find in the GD&T symbols when you put in annotation. Okay, and then here are supplemental problems, but I don't think we need to do that. Okay, and then that's it. Okay, so now what I want to do, I want to show you something. So now I want to change the screen. I want to share a new screen. And can you see?
AutoCAD?
Can you see the AutoCAD screen?
Yeah.
Okay. So what I did, and this is in the book, what I did is I drew the object. Okay, but remember, when you guys do them, I do want you to dimension. I drew this object, and obviously my setup is it inches or metric?
Metric.
Metric, right, because of the size of the dimensions. All right.
I mean, it could be inches, but it would be awful big.
Right, correct. That's a good point. Okay, so now, my unit, okay. So now what I did is I drew that object. Okay, I drew the front view, and then I drew the top view, and I drew the right side view. Okay, now don't worry about these little symbols up here yet. Okay, but what I want to show you is I drew the auxiliary view here. Well, you know, when you draw the auxiliary view, you know, you've got, you know, like I'm missing the oval back here in the, you know, I could put a lot more hidden lines in here. Well, that's confusing, and that's not the important part. The important part is just this area, here, 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 and here. And so what I did is I came up here, I took it one more step, and I did a partial auxiliary view. And then at that point, I can dimension it. Okay, so let's go to annotate, and in this case, I probably have to use aligned. And so then I could click there and then bring it out. And so then you can see that I can put the correct dimension in here now. In other words, maybe this distance is 120.19. Maybe that's real critical. Maybe this something fits on there that has to be that. And so I could do the now I could do the diameter of the hole, and so I'd probably put that right there. But as you can see, now I can dimension this correctly, and then I could come in here, and if I wanted to, I could put a circle around that and maybe take this part and increase it and make a detail so I can show the details of that. So the function of auxiliary views or an extra view are so that you can dimension the true size and shape. Now on the front view, you can give me the true length, and you can give me all these other details. And on the top view also, and on the right side view. But people aren't going to know what the what the diameter of the hole is until you do something like this. Okay. Now, how did I draw this? Okay, what I did, just to show you, to make it easy for yourself, what I do, whenever you're doing an auxiliary view, you've got to remember that the view has to be at 90 degrees to the surface. Okay, so now what's a quick and easy way to do that? You could draw a line and then you could offset it. That's one way. You could draw a line on top of this and then offset it. Or you could do something else here, and that is you can hover over your UCS and right click. Why it doesn't highlight, I don't know. And then I'm going to go to 3 points. You could use other ones too, but I'm going to go to 3 point. And I'm going to go to this corner. And then I'm going to go to this corner and leave it right there. And I'm going to hit enter. And so now, if I turn my grid on, look at my grid. My grid goes in that direction. So now when I draw a ray, and in this case, when I draw guidelines, I can go, because this is my view, I can go like that, and then there it is. I can draw a line perpendicular to that surface. So what I'm going to do now, I did all that. So what I'm going to do now is I put all my ray lines on a different, right here on this layer. And I turn that layer off. So what I'm going to do is I'm going to turn it on right now, just so that you can see how I created all these views. I drew the front view. And when I was okay, let me go back. I'm going to go back to visualize, and then I'm going to go back to the world coordinate system. Okay, so I drew the front view, and then I used ray lines, and I brought them over here to the right side view, and then I brought them to the top view. Okay, and then when I needed to draw my auxiliary views, I think this is where's previous? I can't remember. And then I'm going to go back. Okay, and so then remember when I changed my UCS, let me turn those off. Okay. When I turned my UCS in that direction, then I was able to project all these lines, and then this distance is the true distance. But that's not the important surface, is it? Okay, you can do that, but you know, it's really not the important surface. So then what I did is all I did was copy these lines and moved them out a little more. And so now I have the true size and shape. I have the true size and shape of the object, except I'm missing a line here. So I'm going to click on this line. I'm going to right click and I'm going to copy it to there. Oops. Oh, there it is. Okay, so there it is. That's a complete. And then I can go ahead and dimension this square if I need to. You can put a circle on that and enlarge it over here. Okay, you can like make another copy, enlarge it, change the scale of it, and then you can dimension. Okay. Did we understand that? Do I need to go over it again? The important part is this now, because I did kind of go over it. You notice when I changed the UCS, look up here. You see what it did? It changed my view cube, and so I'm going to try something right now. I'm experimenting here now. Oh, wow. Okay. Hey, how about that? I can change my UCS, and then I can come over here and rotate the arrows, and then let me turn those back on. And then you're working on it as if this was the world coordinate system. So these are all the little things that you discover as you work through this, and so this is kind of cool. So when you change the UCS, you can rotate it so that you're drawing. You're like drawing if it's in the world coordinate system, and then you can get everything pretty accurate. Okay, so now let me go back to this. Oops. Oh. Okay, but then again, see, then you get in trouble. Now I can't get it back to what I had. All right, so here's an example of be careful, because you can get in trouble. Okay, so let's try that. Whoops, don't want to do that. Sometimes when you're changing the UCS over here using you get this kind of shading, and what it is it converts to perspective. So if that happens, you got to click this little arrow over here, and then go to parallel, and then you get back to your. All right. So now let's see if I can get back to where I was. No.
Try just changing the UCS back to the default or something. That'll probably set it so that the rotation goes back to normal.
Yeah, I'm gonna go, you're right. I'm gonna go to here to visualize, and then I'm gonna go to previous. Maybe that's it. Okay,
And then hit like top home or something.
oh yeah, see now, I've really screwed things up.
Oh, just rotate it left with the cube. Rotate it left. Yeah.
There we go.
Yeah.
Okay, so let me review that so that, see, because normally when you hover over the UCS, it would, there would be a little blue square showing up here, but it's not doing that. I don't know if that's part of the new program, but what you do when you hover over the UCS, right click on it, and then you can change it. And I use the 3-point.
Hey, Tony?
Yeah.
Are we supposed to be drawing in 3D modeling now, workspace, instead of the drafting and annotation?
No. The reason I changed it to the 3D modeling, it allows me, good point. That's a good point. I'm going to show you something here. I'm going to go back to the drafting annotation. Okay. Now, my UCS is shoot, it's not going back to normal. Okay. Okay, let me try. Oh, I'm gonna try to do something here. All right, okay. No, you can still do it if you're in the drafting and annotation. You can still hover over the UCS, and you can still right click, and you can still do the 2-point. Okay. and then click here, and then put there, and then hit enter. And you can go back to that, and then you can use your ray lines and draw your auxiliary view. Okay, so what you can do then too, to get back, you can type in UCS, click on it, and come down here and go to world. And then that brings you back to your normal 2D workspace. Now, the reason I went to the 3D is when I go to 3D, it changes this from just the X and the Y. And I thought that I needed to change this so that I could have this function. But apparently, I don't have to, so. Because there's all these little idiosyncrasies that you, sometimes when you switch from one workspace to the other, some functions go away. All right, okay, now, one last thing that I'm gonna show you, then I'm gonna turn you loose, is in the chapter, it talked about these symbols for surface. And as far as assignments go in here, you only need to use this one. And since you don't really have any machining experience and stuff, you can make up your own mind as to where you want to put this symbol. And basically what that is you need to machine it, okay? And so I will show you a website that has all this information, but you don't have to worry about it. I'm giving you this just for information purposes. So what I did though, is I drew these. I drew these according to the chapter. I can't remember what it was, but it gave you some dimensions, okay? And I think this is because of what I'm in. This is 4.5 up and 0.9 or 9 millimeters up. So those are the dimensions. And so now what I did is I just copied that over here, and then I drew that line across here. Then I copied that, and I drew the circle in here using the 3 points, and then I deleted the top line. So now, what you have to do is you have to draw these separate, and then you have to create a block so that you can use them. And so now what you do is you come up here to insert, and you go create block. So I'm going to create a block, and then you have to give it a name. So I'm just going to go SURF, surface. Okay, and then it says pick a point. I'm going to pick a point. So when I bring it in now, I'm going to pick that point, and then I'm going to select the object. So I'm going to highlight all of it. Okay, and so then I hit OK. So now what I could do, once I drew it, I could just copy it. But now I can go back to insert, and there it is. I did it before, okay, but there it is. So I go click, and there it is, bang. And so you come back up here and click on that, and then you can insert it. Now, what you need to understand, because down the road you'll create blocks for different features. Down the road, that block is attached to just that file, to this file, surface finished symbols. Okay? So, whoa. So anyway, just remember that. So to avoid that, say you need to use that symbol in another drawing, I'm going to go and create a new drawing here. I'm going to go to Insert, and I'm going to go to Right block. Let's see. No, that's that. Okay, I don't want that, so I'm going to go back to Insert. I'm going to go to Recent Blocks. Oh, hold on a second. Okay, because I did what's called right block, so I got to go to library. I got to come over here to files. So I got to look for the file. And let's see, where did I put them? I think I put them in chapter 11. Okay, it doesn't show up in here because it thinks I'm still in template. And oh, here we go. I labeled it as this. What I did is I'll explain it in the middle because I know I'm confusing you guys. Okay, so there's the objects. I'm going to open it. Okay, and then I can drag it and put it in here, and then I can drag the next one and put it in here, and then I can drag the third one and put it in here. So what you do is not only do you save it as a block in that particular, in this particular drawing, you can insert it in another drawing, because what I did is when I went to insert, let me go back. Let's go back to this. Okay. Because what I did is when I was here, after I drew these, I went to create right block. Because what you do when you go to right block, okay, here's the block. I'll leave it as objects. Okay, and then you got to make sure that you place it where you want. Okay, and its units is that. And so what you do is you pick a point. So let's do this one. I'm going to pick that point, and then you select the object. Okay, and then you've got to make sure. Okay, I'm going to place it in my desktop, and then here, make sure you give it a name. Make sure you give it a name. I'm just going to go HH, and then there it is, and I'm going to save it, and that's just in the desktop. And then hit OK. And it tells you that it's saved in the desktop on my computer, and it's called HH, and it has a DWG. So now, say I go to a new drawing, or I'll go back. I'll go to Open, and I'm going to go to Desktop. And it should be in here. Where is it?
I think you put it in chapter 11 again, but I'm not sure.
Oh, okay. I might have done that, huh? All right. No, I swear I didn't do that. Okay. Oh, I know what I gotta do. Oh, see, there it is. There's HH. And there's that object. Okay. Now, don't worry too much about blocks. Because in this course, we really don't need to create blocks. When you get into more advanced AutoCAD, blocks are important. Now, in the future, down the road, when you get into industry, if you're working, you might have to create your own library of blocks. Okay, so you'll create blocks and you'll create write blocks. Okay, one last thing I want to show you, and then I'll turn you loose. My famous last words. One last thing. Okay, so I'm going to go to see where it is here. I know what's in here. What did I do with it? Okay, I'm going to show you this. All right. Here is the midterm. I'm going to give you this. I'm going to send it to you with instructions. And what you'll need to create is, let me look here. You'll need to create the necessary.
Tony, do you need to share your screen, or because we're still seeing a blank AutoCAD?
Okay, well, you know, there we go. Thank you, sir.
You're welcome. You don't have to call me sir. I know what that means.
Okay. Okay, you'll have to explain that one to me. Anyway, okay, and so can you see the midterm?
Yeah.
Yeah.
Yeah. In fact, I use this one as an example for sectioning. Okay, so it's probably going to be a piece of cake for you guys, and I'm sure it's in the book. But anyway, what I'm going to have you do is, because I have some other instructions, and I'll give them to you. I'll upload it so that on Thursday, I'm going to make sure everybody can see them. Okay, and then these are the dimensions. It's just going to be inches. Okay, and then what I'll want you to do, I'll want you to draw the front and the top view, and then I'll want you to create an offset section, and I'll have you decide what it's going to be, and then you'll have the front view, the top view, and then between these two views, I'll have you draw the offset section, and then dimension it, and then place it in a title block, and then submit it. So that's what we'll do on Thursday. Okay. So the assignments for this chapter 11 and 12 won't be due till the following Thursday anyway. But on Thursday, just realize that this is what you're going to be doing. Okay. All right.
Okay, so then I have a few questions.
Yeah.
So for the chapter 10, 9, and 10 homework, we're still just doing the regular views of the section view, right?
Right.
And it is still due Thursday, right?
Correct.
Okay.
And by normal view, do you mean we're doing top, like all the normal views, and we're doing a section view of all of those, or are we just doing one, like a section view that's in a line of
Just
whatever?
one
Sure.
section view.
Okay.
And you have to
Each
decide.
question,
You have to decide
each
whether-
question says a specific section type to do.
Well, actually, in the instructions I gave you to do an offset section. Well, you'll have to pick what offset you want. Actually, because it's the same on both sides, you could decide to do a
Half section.
correct, a half section.
And
Thank you,
just-
sir. Oh, just kidding. Okay.
so just to confirm, so for the final exam or whatever that we have to do on Thursday, it's basically just doing one of each of the views and then doing a section view. Is that what you said?
Correct.
So
You'll have the top view and you'll have the front view. And then depending on what you decided on the section view, between those two views, if you want to do it removed, you can do that. if you want to draw it off to the side
But we
or
could
whatever.
just do like an aligned section view of like the top or something.
Correct.
Okay. Do we have to do isometric for that as well?
No, no,
So it's basically just focusing on the section viewing.
correct.
Okay. Which is the one thing that I am struggling with. Perfect.
All right.
Um,
I know you'll do great.
the one thing that I'm confused about is how to get the pattern, the actual like the different ANSI like cast iron pattern, like how to actually import that into the one section.
Okay, can you see the, I'll show you right now. Okay,
Okay.
let me, can you see my screen, the AutoCAD screen?
I cannot see the AutoCAD screen.
Okay, hold on.
I see the P5-32, chapter 5 section.
Okay, let me, okay,
No,
what,
yeah, I can see it now.
okay, so now, let's see, maybe I have a drawing. No, okay. Let me see if I can, oh, okay, I'm gonna illustrate this. Okay, say I cut through this top view. So let's go ahead and draw a phantom line. Let's see if I have phantom line on this. Oops, no. See if I have a phantom line. No, I don't. Okay, so now, all right. I'm going to draw a line. Let me see what layer I want to be on. Okay, I'm going to, oh, I do have a phantom line. Here we go. So I'm going to cut right through the top of this. Okay, so normally I would have an arrow. I would have an arrow on the end of these. You understand?
And you use the leaders for that, correct?
Yeah, I would use a leader, but I'm kind of going fast. Okay, so in other words, I cut through that, right? Okay, so by doing that, okay, this hidden line and this hidden line are going to be solid. This hidden line is going to be gone because I won't be able to see the back. So the only part I'm going to see is where I cut through this. And so let me get rid of this. I'm going to erase those lines. And then remember, the hidden lines become solid. So what I'm going to do, the way I do it, is I'm going to use match properties. So I'm going to click on a solid line, and I'm going to click on that line, and then that line. Okay. Okay, so when I cut through this, I cut through this surface. This is the surface that is cut, that needs to be sectioned. So then you come up here to see the draw menu. You have a little square here, and it says hatch. So this
Hatch,
is
okay, that's what it was.
So you click on hatch, and it gives you a whole new ribbon. And then if you need to, you can, I'll click on this side right here, and you can see all the different hatch patterns.
Oh, I see. And then the normal one we use is like ANSI 31, correct?
Right, that's the normal one. So you click on that, and then as you hover, since the pick point is highlighted, you hover over the area, click on it, and it puts it in. And then for some reason, because of the layer I'm in, Okay, it turns it.
No, I think that's perfect. It matches everything perfectly.
So anyway, so you can see now that is because I was still in the phantom layer. Okay, so if I change that, let's see. Let me change the layer back to,
So we use a
no.
phantom line to when we're sectioning.
Okay, now, I want you to notice, okay, that was ANSI, right? But remember, when I drew this project, it was in millimeters. So the reason it's solid is, and this is important, whenever you're doing hatch, you've got to make sure hatch matches your scale. So if I click on hatch, I come up here and look at my scale. My scale is 1:1, so that's too big. So it makes it solid. So I'm going to change it to 20, and let's see what happens. See, so now I'm going to change it to 50 because, you know, I was in metric. Oh, and then there it is. So I'm going to change, I don't like that. So I'm going to change it to 75. And then there we go. So you've got to remember when you pick a pattern and it fills it up solid, then the scale is wrong. And that's the interesting part of AutoCAD. What they've done is a lot of the, you know, line type scales and the hatch scale and everything, the defaults will not necessarily match your drawing unless you use annotative. So sometimes you got to make sure you click annotative and it would match it.
Now, Tony, is that because you didn't change your limits on your, so you're still on a 12:9?
No, I did change my limits.
Oh, okay, I was just curious if you changed your limits, would it actually change your scaling to match?
Okay, you know what? You know, that's a good point because, you know, all that stuff I never know.
Well, Tony, I just looked in the textbook, and it says that the scale is usually same as the dim scale, whatever that means.
Oh, the dimension scale.
Yeah. It says it's usually the same for hatch pattern as it is as the dimension scale.
Okay, so you would have to go to annotate and then let's see, where's the dim scale here? I have to look.
That's it. And then modify.
Oh, okay,
So
so this is the height. Okay, so, okay, because it's on annotative, so it would probably be right here. Okay, let me do that. Let me change that to 50 and see what happens.
You didn't dimension anything. Oh, you did up there on the top right.
Well, you did do 75 for the hatch, so
Yeah.
maybe.
Well, the hatch is back to 1 because you undid it.
Yeah, see, the hatch is back to 1. So if I change it to 50, it's, yeah. All right. I'll have to look into that. That's good. And that's in the book? I'll have to look that up.
Yeah. I was confused, so I've been reading over the sectioning view part of the textbook.
Okay. All right, now, when you do section now, Carson, when you do section, remember, don't exit out of this unless you go close hatch editor.
Yeah.
Because if you exit out using the exit keyboard button, it erases it. So you got to make sure you exit it. Otherwise, it won't stay. Okay, so remember, when you're in the Home tab, if you need to show a hatch, you go up here to hatch. And if you can go to the right side too, and it gives you more details. You've got boundary, guardian. Okay, but you always want to use pick. Okay. If you use select, then you have to click the boundary. But use the point. Okay.
So that basically would be an example of something that we would have to do on Thursday.
Correct.
Okay, that's not too bad. But I'm assuming the parts are going to be a bit more complicated.
But he showed you
I showed you the part.
Oh, you did?
that 5-32 was the actual one we're going to be.
Okay. Yeah, I
So,
remember now.
are we're gonna be doing that during class, or like how does that work? Like,
During class.
okay.
I'm going to want you to do it during class, and then when you're done, I want you to submit it.
Alrighty.
Could you show us again? I think I was in the restroom.
All right, hold on a second. Let me see if it's still up here. Oh yeah, here it is. Can you see it?
Yep. Oh, that's not too bad.
No.
Oh yeah, we can see it. We can see it, Tony.
So, yeah.
You're gonna duplicate this, and you're gonna duplicate this.
Which I can do.
Yeah, and then I would just copy it, and
And
move
then
it.
basically we would add the section view hatch to everywhere that the hole isn't, correct?
Correct.
And
Yeah. Depending on where you cut the object, you would just make all your hidden lines solid.
So, is there going to be one section, or are we making multiple ones?
No, just one section, whatever section you decide.
Okay.
But you have to decide what section.
But it's going to be an offset.
Yeah, it's going to be an offset. In other words, yeah, I'm not going to say anything else. In other words, okay, I'm going to give you one last clue.
Oh, Tony, you're a sucker.
I know. What? You're going to cut through the holes. Okay, you're going to cut through the holes. That's
yeah, I saw that.
All right.
Do we
Okay.
and then
Right.
do we have to add the machine surface marks too? Or
Yes. Yes.
you want us to do that? Okay. Okay.
All right, is that all?
That's it for today.
Okay. Cool.
And so it's only 9:12, so I'll be here for another hour or so.
Well, I'm fully capable of doing the homework, so I'm gonna go and do that on my own.
Okay, Tony.
But if
One,
I can
two,
find the button, where's the button? I had moved. Okay, I'm falling.
And for
Alright.
9 and 10, it says, is it 4 problems for 9 and 4 problems for 10, or is it just 4 problems total?
Hang on a second. Let me look it up.
Because it just says complete 4 problems, but
Then yeah, between those two chapters.
so I could do like 2 from each.
Correct.
All right, cool. Are you familiar with Creo?
Gosh, no. I played with it a long time ago, but no.
I hate Creo.
Okay, Carson, everybody I talk to says that.
It's so annoying. You know, okay, you're familiar with SolidWorks, correct? Kind of familiar. Even in AutoCAD, when you create a dimension or when you extrude something and it automatically gives references to extruded lines because when it solves, it knows where the edges are. Because like if you go into another sketch, you can snap to edges that technically you haven't drawn yet but exist because of the equation, right? You know what I'm saying, when you
Right.
extrude.
Yeah.
In Creo, it doesn't, it's like, I don't know what that is. You have to tell it every single reference dimension. You have to go back and make every reference dimension, and it doesn't use XYZ planes. It uses datum planes. And Every time you open a program, you have to make sure you set all the datum planes correctly. Otherwise, you'll get 15 extrudes in and you're screwed because everything's backwards. You got to restart. And then also sometimes it'll just crash. You'll be deep into a project and it'll just crash. And then also the 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 directory, you have to go and manually set where you want all of your parts to save in the beginning. So you have to save it. So you first give it a name, which doesn't actually save it. You're just naming it so that Creo has something to call it. And then when you save it, you can't save it as the same name. So you have to save it as something else, but you can't put spaces in it in Creo. So then you have to save it, and if you want spaces in the name, then you have to save another copy of it and put spaces in it and edit the name in your file directory. So I got like 5 files of it when I just want to turn in one. So annoying. I just hate that program so much.
You know what? I'll be honest with you. I don't know why we teach it.
It's just, I even asked him, I'm like, what companies use Creo? And he's like, well, companies like um, Qualcomm use it because he said they like it because it's like more user friendly and that you can't leave things undefined because it automatically dimensions things for you and forces you to input numbers. And then
Qualcomm uses it. Oh, that's interesting.
that's what he said. And then it like won't, like, say you like make like a plate that's like a 100 by 100 and you try to input like a million holes into it, like as SolidWorks would just keep trying to input holes, like is smart enough to know that it can't solve that high of an equation, so it'll just not work.
Jeez.
I guess that's why they like it, but it's just so like like if you get anybody that's less smart than me trying to use that program, they're gonna mess up because it's just so confusing.
You know what's interesting is I can, I think we have access to it, right? You were downloaded it?
Yeah. Oh, you don't even you want to get me started on the download process of that. You would think I'm hacking into like the CIA trying to download that program.
Now, where did you get the information to download it? Because I think I might do it just for the fun of
It's not fun, trust me.
it. Okay.
But my teacher had like a code that he gave us for the student version. It's like SolidWorks, they just get a code.
Okay. I'll email Chris and I'm sure I can get the code from him. All right. Well, sorry to hear that.
It's
But you're not alone. Everybody I've talked to, and I'm talking about some people that are really good in all the software that we offer, and even they say, "Oh,
it's
Creo."
just a headache, honestly.
Well, I know datums are important and everything, but whoever wrote Creo, I don't know. See, 'cause Creo is it was some other name down.
It was called like Easy E or something like that.
Yeah, I think so, and it was all designed by engineers. So anyway, but they have, their mindset's a little different, and the reason Qualcomm uses it, it's probably that's how all their engineers cut their teeth on. So
Well, no, it's actually cool in some of the things that it can do. Like in SolidWorks, if you want to make a hole, there's the hole wizard, right?
right.
But like it gives you so much stuff you can do with hole wizard. Like you can change every single number. Like you can make the funkiest hole you've ever wanted to make. And then there's also cool things like if you have a block, right, and you place a hole on it, and you're planning to extrude it. So instead of doing a sketch first, you actually make an extruded sketch. So you'd extrude, and then you make a sketch in the extrude feature. So you make the feature first. So you define the sketch, but you don't have to dimension anything. So what you do is you put the circle on the block, and it automatically pops up with X, Y, and diameter. And all you have to do is plug in numbers. You don't have to add any dimensions.
Ah, gotcha.
So
Yeah.
you just type in numbers, and then it's literally just when you extrude, it's either extrude or cut, and then there's a number, and that's all that is. It's like it's more basic, but it's
Yeah, but you
complicated
know
in
what?
that the program sucks.
You know what's good about that is you- is you're putting in numbers and exact distances and dimensions. Now that uh, is a plus because you couldn't. It's if you try to do things with the mouse and stuff, even if you set up your grid pattern to just super tiny and snaps, it's still not accurate enough. But if you just are just inputting numbers and distances, then I can see where that's going to be way more accurate. Yeah. Now you're
And
kind of getting me curious. I think I'm gonna download it and play with it
yeah,
on my
there's
spare
just
time.
there's just a couple things like um uh it can be a bit annoying. The textbook's really helpful though, because it does like a step by step. But
Okay.
trust me, the first time I went from doing a step by step to him giving us like complex problems, I sat in front of my screen staring at this thing for like 3 hours because I just was so lost. Because I'm so like the order of operations is different, which is what really confused me.
Well, the fact that you're see how many CAD classes are you in? 3
I'm only in design classes.
or design classes?
So I'm in 101, 110, 203, and 204.
Oh, okay. Yeah, you got a lot on your plate.
It's not too bad because 101 and this class are both using AutoCAD. Um, and then 203 is SolidWorks Creo. And then 204 is, I don't even know what that class is. It's a class.
Okay. Yeah. Yeah. Is Tony in that class with you?
No, Daniel is though. Daniel CF.
Yeah. Uh, Tony's in another class and he says, I don't even know what that is. I don't, I'm going to have to look them up and see what they are. So
204 is, I'm not sure what the name of the class is. Maybe it's like,
is it
uh,
GD&T? You do a lot of
well,
geometric tolerancing?
no, it's like prototyping
Oh,
in
yeah.
3D printing class or something like that. But it's hard because we gotta like do a lot of things that's very hard to do without actually being in person.
Yeah.
Like we're doing this one project right now where we have to design like a connector and then 3D print it, but it's hard because like we can't see it. So it's like it's really hard to see a 3D printed object when you're not actually seeing it.
Right. Yeah. I can see where those kind of classes are, this situation that we're in is, yeah, it's too bad. Well, maybe hopefully down the road, because they've already told me that in the spring it's still going to be online. So that's a bummer,
Yeah.
'cause, for those kind of classes, yeah, you need to be in there using the 3D printer and seeing, because it makes mistakes and yeah. So just be patient. Somewhere down the road, we can do it. Maybe in the fall.
And don't get me wrong, I kind of like online classes. Like today, I got class at 8. I woke up at like 7:50, ate breakfast, and I get on the computer. But if I had class at 8 normally, I have to wake up at like 6:30, take a shower, eat, then I gotta drive there, and then it's like,
No, I agree with you because I'm one of those instructors that gets there early. So for an 8 o'clock class, I'd be there by 7. So that means I'd have to get up by 5:30 or 6. But
yeah.
anyway, Yeah, and this is, I have to tell you, parts of this I really enjoy, only because I interact with the students more. You know, I get to know you guys, and it's kind of,
Well, especially with the small class. I don't know what happened. We had like 15 and now we're down to
yeah,
like
seven.
5 concurrent.
Yeah. So,
Well,
yeah,
did people
I'm sorry we lost two of them. There was one of the students we lost. She was a student in my other class, and she was really good, and I'm surprised she checked out. It might have been a little too basic for her. I don't know.
Well, I'm still confused because when I look on the website, um, on Canvas and I go to people, there's still like
15, huh?
15, 13 people in here, but I haven't seen half these people.
No,
Like, who is Tessabelle Nutter? I don't even think she's ever been to class.
no. In fact, I've emailed her, and I've never gotten a response. So, and I let them know. I says, look, please respond. If you're not, then I got to drop you. So, but what the college is doing is, uh, you know, they're letting people stay in until the very end because of the situation. I don't. They came up with that, which is fine.
Yeah, I just hope people don't like a couple weeks before the end of the semester, they email the teacher and go, I've been gone. What do I need to
Oh no.
do?
Yeah, I won't. I won't do that. Start. Probably starting in a couple weeks. I'll start. Those that don't respond, I'm gonna drop. Well, I hope I don't lose you guys. So,
No, I'm here to stay. Sorry I wasn't here last class. I was having one of those mornings or days where I was like, I'm just, my bed is so comfortable right now. I am just not getting out of bed.
oh, okay. That reminds me. I gotta give myself a note here. Okay. Now on the midterm, you guys, I will. Let's see. I'll probably give it to you on Thursday. I'll send it Thursday morning, uh, so that you guys can. You'll have to upload it and then go
It
for
should,
it.
it shouldn't take that long, correct? It's only the one problem?
Correct. Shouldn't take that long. No.
Okay.
All right.
Um, I,
For me, it takes forever to do anything. I'm just like one of those meticulous people that like takes a century to like draw a line or something because I need to make it perfect or like I have so many doubts that it's just like it just takes forever.
You'll do fine.
one thing that I've learned about making drawings is there's because drawings are never used 100% like reliably for like scale or when the machinist is looking at the drawing to dimension a part. They use the numbers, not the actual drawing. So if your drawing isn't 100% perfect, like if you have a microscopic line that's at an angle and it's supposed to be straight, no one's gonna say anything because they care about the number, not the drawing. So I'm not 100, like, you know what I'm saying? Like the drawing has to be exactly perfect as long as the numbers are correct, you know?
Mr. Trousett, did you happen to get my email that I sent you?